Hi, I am Kaifeng Huang. Next, I will present libharmo, an interactive effort via library version harmonization tool. I will present our work in 5 parts. First is motivation, then we conduct a developer survey. Next is approach, evaluation, and conclusion. First, let's start with motivation. With the increased complexity of modern systems, automated build tools such as Maven and Gradle are introduced to boost development efficiency. Both Maven and Gradle introduce such a mechanism called multi-module or multi-project for the ease of management and build. But it also can bring maintenance cost. For example, duplicate code could emerge between modules, and dependency management could be complicated. Suppose we have a project called FaceLook. At the beginning, 3 teams develop on the project simultaneously. There are 3 main parts: core, web apps, and logging, all of which imports Commons IO version 2.5 as third-party dependency. As it grows more complicated, the project is reorganized into 3 submodules to support parallel development. This time, when one of the development team wants to use a newly added API in Commons IO version 3, they simply update their dependency regardless of the other teams. Besides, there are 2 ways of importing a dependency: hard-coding version in importing tag or referencing a version property which is defined in other POM along the inheritance tree. In this example, one developer imports Guava by defining and referencing a property value version 16. However, when the other team wants to import Guava in the near future, they may miss it and still import Guava in a hard coding way. On the other hand, if web apps import logging as its internal dependency, in this way, a cross-module library version inconsistency happens, which is Commons IO 2.5 and version 3. Besides, although core and web apps depends on same version on Commons IO, this could still incur technical debt in the long-term run if the version is imported in a hard-coding manner. For example, an issue from Hadoop was reported to the projects said that multiple versions of the same library jar are being pulled. Dependent sub-projects use different versions. For example, Common depends on AVRO 132, while MapReduce depends on 130. Since MapReduce depends on Common, this has the potential to cause a problem at runtime. Generally speaking, currently, multi-module mechanism brings dependency hell, especially when there is POM inheritance. In addition, Maven's enforcer plugin fails to detect such inconsistency issues when modules are not interdependent. To that end, we collected multi-module projects, sent out surveys, and crafted the tool on developer feedbacks, and presented our tool called libharmo. And harmonization reports were automatically generated to send back to developers to receive feedbacks on the tools. libharmo tried to solve ICs and FSE issues. It works in 3 steps: IC and FSE detection, harmonization effort calculation, and automatically harmonization with manual check. The above graph shows the overall steps and outputs of libharmo. As for results, libharmo found 621 inconsistencies in 152 projects. We received 39 responses. 12 developers comment that version inconsistency is a problem and our tool and the report are useful. 9 developers discussed the detected inconsistencies. 12 developers asked us to fill a pull request. And the three developers said they used the different versions on purpose. And there are also 3 developers replies that they are no longer related to the projects. So in total, we received 31 confirmation of inconsistencies, and 17 are fixed from 26 projects. Also, 4 developers mentioned the transitive dependencies, which is not in our scope. Next we come to the developer survey. We sent out developer surveys to 443 highly starred Java projects that is built on Maven. We received 131 Java developer responses. Most of them are skilled and have long Java development experience. For the root causes of inconsistency and false consistency, unawareness of the same library in other modules and backward compatibility takes up a large portion, which is 67.1% and 65.8%. For the detection methods on inconsistencies and false consistencies, bugs due to the conflicting library versions and the library API behavior change are 2 major manifestations. Manual investigation of module POM files is the main way to detect, while adoption of Maven's Enforcer plugin takes up 10.5%. As for reasons for not fixing backward incompatibility, intensive library API dependency, different development schedule among modules, and no serious consequences are 4 reasons that developers choose to leave it. As reasons for fixing, to avoid great maintenance efforts in the long run, ensure consistent library API behaviors, and the bugs occurred are 3 major reasons. When asked about how developer fixes, we found that developers prefer to choose newer versions than the currently declared version as the harmonized version. Also, 38.2% choose to harmonized version in modules that only affected. As for fixing efforts, mostly costs hours and days. Locating inconsistent version and determining the harmonized version and refactoring source code are the most time-consuming steps. When asked about how developers expect on the tool, they believe that detecting all library version inconsistencies and suggesting the harmonized version are the most useful features. The above-mentioned developer responses give us insights on tools are needed to locate and harmonize inconsistent library versions. Developers should interact with tools to determine whether to harmonize it or not. And 3. API level harmonization effort analysis is needed to provide developers with API backward incompatibility and API dependency intensity information. Next comes to our approach. The above graph shows the overall approach of libharmo. It takes 3 steps. The first step is detecting inconsistency. First, we generate POM inheritance graph. Then we resolve library dependencies, and finally, we identify which of the library exists an inconsistency or false consistency. The second step is suggesting harmonized version. Given a set of harmonized versions, we analyze harmonizing efforts by extracting and counting library API invocations in projects. We do a library API call graph diff between two library versions. Then we obtain the number of deleted, changed, and unchanged library APIs. Lastly, we interactively recommend the harmonized version with guidance of developers' decisions. The last step is refactoring POMs. Firstly, we locate property declaration of implicit versions and find lowest common ancestor of harmonized POMs. Then we check whether the properties should be deleted and replaced with the new one. Next, come to our evaluation. We elaborate the evaluation to try to answer 4 questions. RQ1 is, can libharmo effectively detect library versions inconsistencies and false consistencies? RQ2 is, what is the prevalence and the severity of the detected library version inconsistencies and false consistencies? RQ3, can libharmo help to save efforts and harmonize library version inconsistencies for developers? RQ4, what is developers' feedback about libharmo? As for RQ2, you can see findings in our papers. As for effectiveness evaluation, libharmo detects 621 inconsistencies and 2,576 false consistencies in 152 and 341 projects. Maven's Enforcer plugin only detects 219 inconsistencies. As for false positive, we sampled 238 inconsistencies and 334 false consistencies using statistical sampling approach. We found 40 false positives for inconsistencies because developers intentionally declared multiple properties for different versions of the same library so as to provide comprehensive supports for different runtime environments. For example, in project memcached session manager, it says that it is a Tomcat session manager that keeps sessions in memcached or Redis for highly available, scalable, and fault-tolerant web applications. It supports both sticky and non-sticky configurations and is currently working with Tomcat version 6, version 7, version 8, and version 9. libharmo achieves a false positive rate of 16.8% for inconsistencies and 0 false positive rate for false consistencies. As for efforts evaluation, 30.6% of inconsistencies have no harmonization efforts APIs, which means that harmonization could be fairly effortless. Averagely, of the 24 called library APIs, there is 1 API deleted and 2 APIs changed in the harmonized version, and the number goes to 63, 1, and 12 when API call number is considered. In other words, averagely, developers only need to focus on the 12.5% of the deleted changed APIs. To ease the harmonization effort, libharmo provides developers with the 13 call sites of the 3 deleted and changed APIs with a detailed API level report. As for developer feedback, we received 39 developer responses. In total, there are 31 inconsistencies confirmed and 17 fixed from 26 projects. Developers replied that our tool and report are useful. The final part is conclusion. First, we conducted a survey with 131 Java developers from GitHub. We proposed libharmo to harmonize inconsistent library versions using our survey insights. Our evaluation on 443 Java projects that is built on Maven show promising results. And last but not least, we will integrate libharmo into build process. And here comes to the end of our presentation. You can contact us or bring up questions via email. Thanks.